What's up, everyone? We're back with another rat lesson. This is on half-life for nuclear chemistry. So, one thing you need to know about half-life is that it is the time required for half of the sample to decay into new or more stable elements. This can be used to date old artifacts, such as rocks and previously living organisms. Every isotope, radioisotope, has their own half-life in table N of your reference table. The shorter the half-life, the less stable it is. So remember that. The shorter the half-life, the less stable it is. Another thing about half-life is you really need to know the formula to calculate for the time it takes for like half-life. So this question, if a sample of iodine 131 has an original mass of 64 grams, what mass would remain after 32 days? So you want to find the mass of this original 64 grams in 32 days. So a formula we can use is number of half-life periods is equal to time over half-life period. This little t is the time. This big T is the half-life. The half-life period is also known as arrows. You'll see what I mean by this later. So this is our formula to calculate for basically all these. So if this, so let's plug this in. Sample of ith 131 has an original mass of 64 grams. That's remain after 32 days. So you would need to put the number of half-life periods. We don't know what that is yet, but what we do know is the half-life of this, if you look on table N, and the number of days, which is time. So we have 32 over the half-life, which I have to go look at. I-131 right here, 8.021 days. 8.021 days. This is our half-life. So this is old enough. So time. This is our half-life. So basically we just do like basic division for this one now. 32 divided by 8.021 and we get around 4. So our half-life period is 4. This is not our answer. This is how many arrows this is. So 4 arrows. Alright, so this is where the arrows come into something very important. So since we need to find 64 grams, we basically have 64 4 times, like for the 4 arrows. So 64, 32, this is our first arrow. Our second arrow is 16. Our third arrow is 8. Third arrow. And our last one is 4. It's our fourth arrow. So our final answer is 4 grams, which is there. So another thing you'll usually see here is that they will give you the half-life and the period already, and you need to find the time. So what is the total, for example this one, what is the total number of years that must pass before only 25 grams of an original 100 gram sample of C14 remains unchanged? So basically for this one, what you need to do is 100, try to get this to 25 now. So 100, half that is 50 and half that is 25. These are 1, 2 arrows. So our half-life period is 2. Now we use this table N to go look for our half-life. The half-life for C14, right? Yeah, is 5,715 years. So basically, we're trying to solve for time now. So we have 2 is equal to time over the 5,715, right? Yeah. 5,715. 5,715. Okay. Now we just plug this into the calculator. You can do this and like cross multiply. And then you get 5,715 times 2, and you get 11,430. Was it days? It's in days, right? Oh, years. So the closest answer to this is C, 11,460. So this would be our answer. This one asks for days again, which is similar to this question. We can do this question too, whatever. How many days are required for 200 grams of radon 222 to decay to 50 grams? Alright, so they're asking for days again. So we'll go from 200 to 50. So 200 after it's 100. 100 is 50. This is also 2 arrows. So our half-life period is 2 again. So 2 is equal to time over radon 222. We look on table N. It's 3.823. 3.823. Cross multiply again. 3.823 times 2 gets 7.646 equal to T. And that would be C. Now this one is a little bit different. It's a similar concept to this one, but instead of solving for time, you're solving for the half-life. So basically, for this question, half-life of radioisotope at 25 grams of an original 200 gram sample remains unchanged. So basically go from 200 to 25, 200, 100, 50, 25. This is 1, 2, 3 arrows. So our half-life period is 3. So now we use our formula. 3 is equal to, so we're given the time this time, so it's 11.46. 11.46 over big T, because it's a half-life and we don't know what that is. So you would let's multiply, I guess, and then this will become 3T is equal to 11.46. Now you solve for T, and 3 T is equal to, you divide it, 11.46 divided by 3, you get 3.82. I'm pretty sure this is in days. Yep, it's B. That's all you need to know on finding half-life.